So good morning, welcome to Sakal Vidya YouTube channel. Very good morning. I am okay. Thank you for your concern. Okay, Arun Kumar, Radha Reddy, Gopalam Sai, Arjun Kumar, Balu, Mudiraz, Pramodini, Lakshman, Sarath Sai, Nageshwar Reddy, Ramulamma. Okay, thank you. Nodal, thank you, thank you, thank you, thank you. Thank you for your concern. Okay, now Amshi, Nageshwar Reddy Garu, Lakshman, Putluru Nageshwar Reddy. Right. See, I need to complete even mathematical induction chapter. After completion of mathematical induction, definitely vectors will be started. So I'll give the even schedule also today, because in this month only total syllabus I will try to complete. The most of the syllabus will be completed, don't worry. So stay tuned to our classes and even watch the previous videos also for the sake of your revision purpose. So mathematical induction. Mathematical induction, this is just 1 or 2 marks. That means 1 or 2 questions may appear in the examination. This is the weightage of this chapter, mathematical induction. Good morning, good morning. Govind, Suma, Sadhu, Prema. Okay. See, the first concept we have here two types. The mathematical induction are two types. So one is principle of finite mathematical induction. Mathematical induction. Second, principle of complete mathematical induction. Complete mathematical induction. Okay. So Maruti, after a long time, Sheikh Abdul, Edla Ganesh, Narla. Principle of finite mathematical induction, principle of complete mathematical induction. Actually, this mathematical induction is based on Peano's axioms. But I don't go for in detail about the free history about the mathematical induction because it's a competitive entrance examination. Let us go straight forward. We shall have the discussion on principle of finite mathematical induction and principle of complete induction. Right? First one is principle of finite mathematical induction. Mathematical Induction. Simple day-to-day life example is induction means just think of tamarind fruit, immediately saliva come in our mouth, just like induction. That's all. Induction. You need to use at least offline session you need to use. Let us say like this now. For n belongs to n belongs to set of natural numbers. Let P of n be a statement. Statement means mathematical statement. Statement. For n belongs to n, let P of n be a statement. Statement in terms of n. In terms of n. If P of 1 is true, or if P of 1 is true, P of 1 is true and P of k is true, that implies P of k plus 1 is also true. K plus 1 is also true. Then the given statement P of n is true for all n belongs to n. We can conclude like this. So the most of the theorems mathematics, yes, when the cycle started, from falling of cycles when one is pushed, exactly correct, just like a railway bogies. So let P of n be a statement in terms of n if P of 1 is true and P of k is true. Now with the help of these two conditions we need to prove that P of k plus 1 is also true. Then we state that for any value of n belongs to natural numbers, we can say that P of n is always true. This is called finite mathematical induction. Finite mathematical induction means first we confine to 1, next we assume that it is true for k, n is equal to k, and from that actually we will it will be proved P of k plus 1 is true, then P of n is always true. That is statement holds good. The most of the theorems will be solved with the help of mathematical induction. Even binomial theorem, even De Moivre's theorem, everything will be proved with the help of finite mathematical induction. Example, you take it. Example, if n belongs to n, then cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta. So this will be proved with the help of mathematical induction only. Even if n belongs to n, then x plus a whole to the power of n is equal to nc naught x to the power of n plus nc1 x to the power of n minus 1 a plus nc2 x to the power of n minus 2 a square plus so on dash dash plus ncn a to the power of n. So just for example, just I consider the two theorems. These two theorems, not only these two theorems, most of the mathematical theorems will be proved with the help of mathematical induction. Generally we use finite mathematical induction. Okay, now second one, principle of complete complete mathematical induction. Mathematical induction. Mathematical induction. So that means actually let n belongs to n, let P of n be a statement P of n be a statement in terms of n, in terms of n if P of 1, P of 2, P of 3, and so on, P of k minus 1. That means we need to check from 1 to k minus 1 are true. Now you need not check for P of k. So that implies P of k is also true. P of k is true. Then P of n is true for every n belongs to n. This is called complete mathematical induction, but most of the cases we use finite mathematical induction only. Sometimes we use complete mathematical induction. So this is complete mathematical induction. So now some important points need to be discussed. Some important points. First point. A comma a plus d comma a plus 2d and so on, a plus n minus 1 into d are in arithmetic progression, because in most of the problems we come across the general form of the arithmetic progressions. The problems will be related to the arithmetic progression. That means we should know first of all what is the general form of the arithmetic progression. So if a comma a plus d, a plus 2d and a plus n minus 1 into d are in arithmetic progression, a is the first term, the second term, third term, this will be the nth term, and next so nth term Tn equals to nth term, the nth term equals to a plus n minus 1 into d. In most of the problems we need to find out the nth term with the help of arithmetic progression, if it is arithmetic progression, where a is the first term, and d is the common difference. So just I revise, I need not go for in detail. Second is sometimes we need to find out Sn. Sn stands for sum to the first n terms. Sum to the first n terms is equal to, is given by n by 2 times 2a plus n minus 1 into d. So this can be written as n by 2 into a plus l also. where L is the last term. L is the last term. That is L is equal to A plus n minus 1 into D, which is nothing but Tn only. This is just brief discussion about the arithmetic progression. This concept is enough for us for a while. So regarding to as far as this chapter is concerned. Now second point we need to discuss geometric progression also. Second point, AR square, so on, AR to the power of n minus 1 form geometric progression. Then first point, Tn, nth term. So nth term is equal to A times r to the power of n minus 1, where A is the first term, A is the first term, and R is the common ratio. R is the common ratio here. Common ratio. Yes. Common ratio. Second point in this subpoint we shall discuss sum to n terms. Sum to the first n terms equal to A times r to the power of n minus 1 by r minus 1. Here r greater than 1. Suppose this can be written A into 1 minus r to the power of n upon 1 minus r. Even this is mod r is less than 1. Mod r is less than 1. Two conditions are there, when r greater than 1 and when r is less than 1. So next, third point, in an infinite GP, geometric progression, S infinity is sum to infinity terms. Sum to infinity terms is given by A upon 1 minus r, provided mod r is less than 1. Because whenever infinity terms means r tends to here infinity, with the help of limit concept, r is very smaller value, because less than 1, r to the power of n tends to 0. In the place of r to the power of n 0, you get a by 1 minus r. A by 1 minus r. Next, third one. A comma A plus dr comma A plus 2dr square A plus 3dr cube r cube and so on dash A plus n minus 1 into d r to the power of n minus 1. Actually, some of our viewers asked me to explain about arithmetic geometric progression. Arithmetic geometric progression. So arithmetic geometric progression means, you observe here, the first term is a into 1. This we can write like this. So we can write like this. a into 1 plus a plus d into r, you can write it, plus a plus 2d into r square, you can write, and so on dash dash. See, if you consider first factors a plus 2, a plus d, a plus 2d, the first factors are in arithmetic progression. Take second factors 1, r, r square are in geometric progression. That's why this is called arithmetic geometric progression. This is the general form of the arithmetic geometric progression, right? In this nth term is equal to a plus n minus 1 into d whole to the power of r to the power of n minus 1, where r is the common ratio of 1 r square, that already we have discussed. Okay, right now. Second point is Sn, sum to n terms. Sum to n terms is equal to a by 1 minus r plus dr into 1 minus r to the power of n minus 1 upon 1 minus r whole square minus a plus n minus 1 into d r to the power of n by 1 minus r. This is sum to n terms. Next we can find out sum to infinity also, because this is the geometric progression is this sum to infinity. Sum to infinity. Sum to infinity means here this r to the power of n and r to the power of n minus 1 becomes 0. So this becomes 0, this becomes 0. That's why very simple, you get a by 1 minus r plus dr by 1 minus r whole square, provided mod r less than 1. This is about AGP, arithmetic geometric progression. Next now, so one example let us discuss. One example. Example. Sum of infinite terms of 1 plus 3x plus 5x square plus 7x cube plus dash dash infinity mod x less than 1 is. So this question was asked in previous Ecet examination only. That means actually the sum of the infinity terms of 1, 3x, 5x square, 7x cube, dash dash infinity. See, now you observe this series. Actually, solution. First factors 1, 3, 5, 7 dash dash are in arithmetic progression. Am I correct? Second factors. Second factors means 1 x, x square, x cube dash dash are in geometric progression. That means given series is in AGP, arithmetic geometric progression. Here we are asked sum to infinity. Sum to infinity means actually what we need to find out actually. From first factors we need to find out A and common difference. Common difference means 3 minus 1 is the common difference. So here we can write A equals to 1, common difference equal to 3 minus 1, A2 minus T2 minus T1 2. And from the second factors we need to find out A value once again, A1 only. Here common ratio T2 by T1 x by 1 x. Now S infinity for AGP is, what is the formula? A by 1 minus R plus dr by 1 minus R whole square. Let us substitute the values. 1 upon 1 minus x, d is 2x upon 1 minus x whole square. Just we need to simplify this one. Here 1 minus x whole square is the LCM. 1 minus x plus 2x. We have 1 minus x upon 1 minus x into 1 minus x. The common factor cancel. We have 1 upon 1 minus x. Or we can write, this will be, what we can write? Sorry, this will be plus. I did mistake. So this equals to 1 plus x upon 1 minus x whole square. This is the answer. That's all. So some important points. First one, sum of the first n natural numbers. Sum of the first n natural numbers is sigma n. Sigma n equals to, you can write 1 plus 2 plus 3 plus so on dash dash plus n equal to n times n plus 1 by 2. N times n plus 1 by 2. Second, sum of the squares of the squares of the first n natural numbers. N natural numbers is denoted by sigma n square is equal to 1 square plus 2 square plus 3 square plus dash dash plus n square equal to n times n plus 1 2n plus 1 upon 6 upon 6. Right. Sum of the cubes of the first n natural numbers. N natural numbers. That is sigma n cube. Sigma n cube is equal to 1 cube plus 2 cube plus 3 cube plus dash dash plus n cube is equal to n square n plus 1 whole square upon 4. That means we can relate third and 1. Therefore, we can remember like this. Sigma n cube equals to sigma n whole square. This we can remember. Now fourth, sum of the first n odd natural numbers equals to 1 plus 3 plus 5 plus so on dash dash plus 2n minus 1. So this equals to, we can write sigma 2n minus 1. Sigma 2n minus 1 means 2 common, 2 sigma n minus sigma 1. 2 times n into n plus 1 by 2. Sigma 1 means 1 is added for n times. 1 plus n times. That is n. 2 gets cancelled. This is n square plus n minus n. Cancel n square. Okay. The sum of the first n odd natural numbers is 1 plus 3 plus 5 dash dash plus 2n minus 1. This is the nth term of the first n odd natural number. That is n square we have. Next, sum of the first n even natural numbers. Even natural numbers equals to 2 plus 4 plus 6 plus and so on. Nth term will be 2n. Here see 2 common. You have 1 plus 2 plus 3 plus dash dash plus n. Already this is nothing but sum of the first n natural numbers. 2 times sigma n. That is 2 times n plus 1 by 2. 2 gets cancelled. We have n square plus n. That's all. N square plus n or n into n plus 1 or n times n plus 1. Now sixth one, 1 into 2 plus 2 into 3 plus 3 into 4 plus dash dash n terms is equal to. N terms is equal to. Here see, in this problem, enter first factors 1, 2, 3 are in AP. Second factors 2, 3, 4 are in AP. First, let us find out nth term of first factors. Nth term of first factors, say Tn. So small tn equal to a plus n minus 1 into d. A is 1 plus n minus 1 into d. D is 1. N minus 1 plus 1, n. So say this is t dash n, nth term of the second factors. 2 plus n minus 1. That will be n plus 1. So therefore, nth term of the series, nth term of the series this series, nth term of the series is equal to Tn multiplied by T dash n, that is n times n plus 1. So if you want to find out Sn, sum to n terms of this one, apply sigma of n times n plus 1. This we can write sigma n square plus sigma n. Sigma n square is n into n plus 1, 2n plus 1 upon 6, plus sigma n is n times n plus 1 by 2. Let us take n times n plus 1 by 2 common. N times n plus 1 by 2 common. What do you get now here? 2n plus 1 upon 3 plus 1. This equal to n times n plus 1 upon 2. Here 3 is the LCM. 2n plus 1 plus 3. So this equals to 2n plus 4, 2 common 2 gets cancelled. N times n plus 1, n plus 2 upon 3. Upon 3. Right. See now 1 into 2 plus 2 into 3 plus 3 into 4 and so on, n terms is equal to n times n plus 1, n plus 2 upon 3. That means actually you can observe the pattern in this one. You need not do any lengthy way. Very simple manner we can solve all these problems. Don't worry, but I have given just the simple proof. For even it can be extended for 3 factors, 4 factors, 5 factors, even 6 factors also we can apply. So that means actually what is the logic means, very simple logic. You see 1 is there, here n, 1 is there, n, 2 is there, n plus 1, and one more term you will get it, n plus 2 upon 3. That's why now directly we can write now seventh one, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus dash dash n terms is equal to, now we can write n times n plus 1 times n plus 2 times, and next 4 factors write down, n plus 3 upon 4. Directly we can write, no problem. Now eighth one, 1 into 2 into 3 into 4 plus 2 into 3 into 4 into 5 plus 3 into 4 into 5 into 6 plus dash dash n terms. This is my intention, that's why I explained the sixth concept. Everybody will write n, n plus 1, n plus 2, n plus 3, n plus 4 upon n plus 4. This is 1, 2, 3, 4, 5. That's all. Very simple way. Oh, how are you, Kodala Kalyani now? Are you okay? So after that completion of the live session, take care Kalyani. Take care Kalyani. Don't worry. Okay, okay. See, everybody is actually, oh sorry. Okay, okay, okay. So you might have followed actually here. Why should I explain this concept? With the help of this one we can find out the induction. With the help of induction actually we can write 7th, 8th and like that. Anything we can write it. Okay, now next one, 9th concept. This is very important. 1 square minus 2 square, alternative series this is called, plus 3 square minus 4 square plus 5 square minus 6 square plus dash dash n terms. This equals to minus n times n plus 1 by 2. N is even. N is even. If n is even, you need to use this formula. Same, n times n plus 1 by 2, n is odd. N is odd. N is odd. Okay, that means somebody told me, given the suggestion that trial and error method. Here also trial and error method also we can observe. See, trial and error method. See the hint. Take first two terms. 1 square minus 2 square. See, 1 minus 4 is minus 3. This is left hand side. No, this will be the RHS. See, RHS, n is even. N is even means this formula. Minus of 2 times 2 plus 1 is 3 by 2. 2 gets cancelled. Minus 3. That's why this formula we need to take it. So this is first case. Second case, odd terms you take it. Left hand side. Odd terms means 1 square minus 2 square plus 3 square. So 1 square is 1 minus 4 plus 3. So 1 square is 1, 2 square is 4 minus 4, 3 square is 9. That is actually how much? 6 you will be getting. RHS. So take this formula. 3 into 3 plus 1, 4 upon 2. 2 1 ja, 2 2 ja, 6. So like this, I know this method also, trial and error method also. But So in general, total mathematical induction chapter will be completed using trial and error method only. Don't worry. But so these we can remember very easily by observing the pattern. What is the pattern is there in the given problem? Look for the pattern. Just look for the pattern. That's all. Okay. So everybody, let us pray for the sake of Kodala Kalyani. Get well soon. May God bless her. And one more important point I am going to discuss. This is very important. The most of the time this question, based on this one, question has been asked in the examination. The important, very very important. Everybody need to uh, check this one. See, Kalyani, you have so many prayers, almost more than some lakhs of persons will pray to get well soon. Okay, take care, Nana. The sum in the nth bracket, this is very important, nth bracket of 1 plus 2 plus 3 in the first bracket, plus next is 4 plus 5 plus 6, and plus dash dash is. So this you remember, that bracket is n times n square plus 1 by 2. Okay. The sum in the nth bracket, not sum of all the terms. For example, third bracket is there. What is the sum? 5 plus 4, 9, 9 plus 6, 15. Third bracket means in the place of n, third bracket, 3 you need to substitute. You check now, third bracket, sum in the third bracket. 4 plus 5 plus 6, 15. So this you can say S3 also, no problem. So we know this is Sn. Now check S3. 3 times 3 square, 9 plus 1 upon 2. Now 3 times 10 upon 2. 2 1 ja, 2 5 ja. Yes, 15. Both have been matched. This is the hint. So that means particular bracket we can find out. I think most of the cases actually 50th bracket you may be asked. The sum in the 50th bracket. Sum of the numbers in the 50th bracket. For example, if you are asked in this one, 50th bracket means S50. S50 is equal to 50 times 50 square plus 1 upon 2. 25 times 50 square is 2500, 01, 2501. So 2501 ja 25. Next 625. I think this one is the answer. Okay, I give one question now. You try to find out. Yes. 2501 into 25. What is the answer? Anybody? What is the answer? That means question may be like this. Question may be like this. The sum in the 50th bracket of 1 plus 2 plus 3. They won't change also. Same numbers will come in the examination. 4 plus 5 plus 6 dash dash is equal to. Answer is 62,525. This is answer. So let us discuss one example now. One example. So let us discuss one example. Sum to n terms of 1 upon 1 into 4 plus 1 upon 4 into 7 plus 1 upon 7 into 10 plus dash dash is. So let us do this problem. So first factors write down. What are the first factors? First factors are 1, 4, 7 are in arithmetic progression. So in this case, first let us find out nth term, Tn. A means 1, n minus 1 into D. D means 4 minus 1 is 3. This is 3n minus 2. Next, second factors. Second factors 4, 7, 10 are in arithmetic progression. That's why only we should be familiar with the arithmetic progression concept. Here, nth term let us find out. Say t dash n. First term is 4 plus n minus 1 into common difference. What is the common difference? 7 minus 4 is 3 only. Here also 3. This is 3n minus 3 plus 4. 3n plus 1. Therefore, nth term of the series is 1 upon 3n minus 2 multiplied with 3n plus 1. This is the nth term of this series. But we are asked sum to n terms. So now consider Sn equals to 1 upon 1 into 4 plus 1 upon 4 into 7 plus 1 upon 7 into 10 plus dash dash 1 upon 3n minus 2 3n plus 1. So this is equal to, we can write sigma 1 upon 3n minus 2 into 3n plus 1. N value takes from 1 to n. Substitute 1 here, 3 minus 2 is 1, 3 plus 1 is 4 only. Now the partial fractions of this we need to find out. Partial fractions. 1 by 3n minus 2 into 3n plus 1 partial fractions we need to write. So that's very simple. The difference of these two is 3. 3n plus 1 minus 3n minus 2. 3n plus 1 minus 3n plus 2. 3n cancel 3. That means this we can write partial fractions 1 upon 3 minus 1 by 3n minus 2 minus 1 upon 3n plus 1. These are the partial fractions of this one. So we need to take the help of partial fractions also. So that's why now this can be written sigma n is equal to 1 to n 1 upon 3n minus 2, 1 by 3 common out, minus 1 by 3n plus 1. Now substitute the values. 1 by 3 times, first n is equal to 1, you get 1 by 1 minus 1 upon 3 plus 1, 4, plus next substitute the 2, 1 upon 4 minus 1 upon 7, substitute 3, 1 upon 7 minus 1 upon 10 plus dash dash 1 upon 3n minus 2, 1 upon 3n plus 1. So this is called, actually mathematically, this is said to be telescoping series. Telescoping series. You are going to study in post-graduation or even BTech also, series and sequence and series you will study. In that telescoping series also you will study. So what will happen means minus 1 by 4 plus 1 by 4 cancel, minus 1 by 4 plus 1 by 4. So this minus 1 by 10 plus 1 by 10, the plus this also will be cancelled now. Only remaining what we have here. Yes, see, very interesting. We have 1 by 3 of 1 minus 1 by 3n plus 1. Here 3n plus 1 is the LCM. 3n plus 1 minus 1 to 1 by 3. 1 cancel, 3n by 3 is n upon 3n plus 1. Don't worry, trial and error method also we can do in the problems. Regarding the problems, you need not do this lengthy way. But for your better understanding, I am explaining to get the concept of this one. But don't worry, all the problems can be solved in the fraction of seconds only, just by substitution, trial and error method only. But for the sake of better understanding, let me explain all these concepts. Yes. For example, is equal to, answer will be n by 3n plus 1. You can verify like this. Take left hand side. Find S1. S1 means 1 by 1 into 4. 1 by 4. Among the options this will be there. So RHS also S1. S1 means 1 upon 3 plus 1. 1 upon 4. Yes, this will be the right option. Options will be selected only by substituting the options only. We need to substitute n is equal to 1 and check first term of the left hand side value and options. If two options are actually same, then go for substitution, n is equal to 2. If three options, then n is equal to 3. So most of the cases the problem will be solved n is equal to 1 only. Sometimes you need to take n is equal to 2. Better you take n is equal to 2. That will be good for us. So thank you. So tomorrow the evening session actually we shall continue that remaining problems are there in theory of equations. Few questions I need to discuss on reciprocal equations. Yesterday I forget and I left it. That I will discuss. And moreover, definitely I will give the plan today, timetable also. Let me complete even vectors also, because vectors is there. by differentiating the options also. Integration also, sir, by differentiating options. Differentiating options takes a lot of time. So don't do like that, better actually. Yes, by differentiation also, same you will get the answer. Okay, lot of the methods are there. I hope you might have followed the concepts. If you know the concepts, any problem, even it may be JE mains or advanced, whatever problem, you can solve it. Can we use an by an plus nd? Why not any? There are so many logics we can use. Make use of that one. Right. Okay, what sort of issue we have? Right. Okay. So all of you just once again go through the playlist actually. Like, subscribe and share to your friends too. Right. Bye bye. Kalyani, take care.